In the vast tapestry of our galaxy, where frozen giants drift in silence and barren rocks circle faint suns, there is one planet that refuses to play by the ordinary rules. A world that, against all odds, feels familiar. Its name is K2-18B. It circles a dim red dwarf star, more than 110 light-years away in the constellation of Leo. To the naked eye, it's invisible, just another point in a sky filled with billions. But to our telescopes, K2-18b has become one of the most extraordinary discoveries of the last century. Because this alien world may be the closest thing we've ever found to Earth. And now, thanks to the James Webb Space Telescope, it may also be the first place beyond our own planet where we see undeniable signs of life. For years, astronomers suspected something strange about K2-18b. Early scans hinted at water vapor. Later came traces of carbon-based molecules, methane, carbon dioxide, chemicals often linked to life. But it wasn't until Webb turned its eye toward this distant world that the real shock arrived. The data revealed atmospheric fingerprints that could no longer be explained by chemistry alone. Signals so strong, so clear, that they forced scientists to consider the unthinkable. The presence of biosignatures, gases that, on Earth, can only be produced by living organisms. For the first time in human history, the possibility that we are not alone isn't just speculation. It's evidence. What is K2-18b? K2-18b is what scientists call a Hycean world, a hybrid between a rocky super-Earth and a gas-rich mini-Neptune. It's far larger than our home planet, measuring 2.6 times Earth's radius and nearly 9 times its mass. Yet, unlike the massive gas giants in our own system, K2-18b sits in the delicate, Goldilocks zone of its star, the band of space where temperatures could allow liquid water to pool on the surface. Imagine a planet covered in a global ocean, wrapped in a thick hydrogen atmosphere. A natural greenhouse that keeps temperatures mild. A shield that blocks radiation from its unstable red dwarf star. Beneath those clouds, scientists now believe, may lie endless seas capable of hosting life. And then came the breakthrough. Webb's infrared instruments didn't just confirm water vapor. They revealed traces of methane and carbon dioxide, building blocks of organic chemistry. And hidden in the data was something even more astonishing. The shock of DMS in 2025. Astronomers analyzing Webb's mid-infrared spectrometer found spectral signatures that stopped them cold. Among them was dimethyl sulfide, DMS, a compound that, on Earth, is almost exclusively produced by living organisms. Specifically, by microscopic marine phytoplankton drifting in our oceans. Finding DMS in an alien atmosphere is like finding a message in a bottle. On our world, there is no known geological or chemical process that produces it in large quantities without life. To make the case even stronger, scientists also detected dimethyl disulfide, DMDS, another molecule tied to microbial activity on Earth. Together, in a hydrogen-rich environment filled with water vapor, these molecules tell a story that can't easily be ignored. A story where something on K2-18b may already be alive. What kind of life could thrive there? If K2-18b truly harbors life, what might it look like? The simplest answer is microbial organisms. Tiny alien cousins of phytoplankton, drifting in vast alien oceans, feeding on faint rays of red starlight. But some scientists allow themselves to dream further. Perhaps early multicellular life has emerged, filter feeders moving through nutrient-rich seas, or organisms evolved to withstand low gravity and thick pressure, some even breaching the atmosphere like the flying fish of Earth's oceans. If so, K2-18b may resemble not modern Earth, but ancient Earth, a snapshot of our own planet 3 or 4 billion years ago, when life was first beginning to transform air and sea. And just as early Earth life reshaped our atmosphere with oxygen, perhaps K2-18b's oceans are now in the midst of reshaping theirs. The discovery of possible alien biology raises a profound question. Should humanity try to communicate? Some scientists urge caution. They argue that even if life exists, it may be fragile, primitive, and easily disrupted by interference. A signal from Earth would take 120 years to reach K2-18B, and another 120 years for a reply. But what if our curiosity invites consequences we cannot control? Physicists warn that broadcasting our presence could be reckless, exposing us to civilizations we are not ready to encounter. Ethicists insist that alien ecosystems deserve protection from contamination, just as we safeguard fragile habitats on Earth. Others, however, believe the universe is already listening. Our radio transmissions have been leaking into space for a century. If anyone advanced lives on K2-18B, or anywhere nearby, they likely already know we exist. To them, our silence might be more telling than our words. The next chapter of exploration, we cannot yet reach K2-18B. With today's propulsion, the journey would take millennia. But humanity is already planning the next steps. New telescopes like LUVOIR and HABEX are being designed to study exoplanets with even sharper vision, capable of not just detecting molecules but mapping weather patterns and perhaps even continents. International collaborations are forming around the idea of long-term monitoring of K2-18B. Meanwhile, ambitious projects like Breakthrough Starshot propose sending microscopic probes propelled by lasers at 20% the speed of light. If successful, such probes could reach K2-18B in just 500 years, an impossible wait for us, but a blink of an eye on cosmic timescales. For now, we watch. We study. And we imagine. The human response, the cultural impact of K2-18B is already enormous. Across the world, faith leaders, philosophers, and thinkers are grappling with what it means if we are no longer unique. Some see it as proof of a grand design, a universe seeded with life. Others feel unease, warning that humanity is not prepared for the implications. Social media is ablaze with conversations. Documentaries, novels, and films are already reimagining K2-18B as both a hope and a warning. Governments tread carefully, caught between wonder and caution. And yet, beneath all the debate, something rare is happening, a global sense of unity. For the first time, the question, "Are we alone?" may finally be shifting toward an answer. A reflection of ourselves. Perhaps the most profound truth about K2-18B is what it shows us about ourselves. A planet covered in oceans, orbiting a distant sun, perhaps filled with microbial life. This is not just an alien world. It is a mirror. A glimpse of what Earth once was. A reminder of how fragile, how unlikely, and how precious our own biosphere is. If K2-18B truly harbors life, it will teach us not just about the cosmos, but about our origins, and perhaps our destiny. Conclusion: K2-18B is no longer just a line of data in a telescope's logbook. It is a window into possibility, a world that whispers across the stars that life may not be rare, but inevitable. The signs are there: water vapor, carbon compounds, and now, the molecular fingerprints of biology. Humanity stands at the edge of something extraordinary. Not the edge of belief, but the edge of confirmation. And as we look outward, across the cold and the dark, we are not just discovering the universe. We are discovering ourselves. So the question is no longer, are we alone? The question is, what happens next? Do we send a message? Do we remain silent? Or do we learn to listen carefully to the first whispers of life beyond Earth? Because if K2-18B is alive,